So hello everybody. So yeah, as I had mentioned, right, the previous video, right, that presentation, we had kind of gotten through looking at the nervous tissue from a standpoint of how is it that, right, that nerve impulse or that action potential, how is it that actually, right, generates that impulse, right? We talked about the different gates, like the mechanically gated channels and the voltage gated channels, right? We talked about the chemical key, if you will, right? So we'd gotten through that, and then we'd already talked about kind of how the body compartmentalizes the different neuron or the different nerves in the body, right? Into, for instance, the brachial plexus, how that, right, gives rise to all of the different nervous tissue in the upper extremity, and then the brachial plexus carries that the brachial plexus carries those neurons, compartmentalizes them into different spinal nerves. Those spinal nerves enter into the spinal cord, and eventually it reaches the brain. But there are some specialized nerves which do not enter into the spinal cord, right? They actually exit the brain directly. Right? There's 12 of them. Right? They're called the cranial nerves. Right? So even without talking about what it is that they do, without talking about their function, if we just take a step back and just think about, right, some of the functions that, or we think about some of the potential functions that these nerves carry, right? If there are nerves which exit the brain directly, right, those nerves, if you just think about it, probably carry some of the most important functions that our body can actually carry out. Right? It doesn't go through the spinal cord. Right? The other part of the reason why that is, so reflexes wise, how I'd mentioned, right? Many reflexes are initiated in the spinal cord. For instance, you go into a doctor's office, the knee jerk, or they kind of hit your patellar ligament with the reflex hammer, and your leg kind of swings, makes this kicking motion. Part of what the cranial nerves are responsible for is transmitting, again, for instance, the special senses, vision, taste, hearing, right? Transmits those into the brain. And some of them transmit to the specific parts of the brain which are associated with reflexes. For instance, when we talked about the midbrain we mentioned it plays a role in auditory and visual reflexes. Right, somebody drops a loud book behind you. What do? You snap your head around and look directly where the sound was coming from. Right, so that's other part of the reason, or other part of what these cranial nerves allow for. Right. So the first cranial nerve, again, this is cranial nerve 1. This is the olfactory nerve. Olfactory nerve. This transmits your sense of smell into the brain. Right. This bypasses, right, the spinal cord. Right here in the nasal cavity, we can see. If you remember, in the kind of the roof of the nasal cavity, there is the ethmoid bone. There are these little tiny holes called olfactory foramina. They are what allowed these little tiny olfactory neurons to enter up into the cranial cavity. When they do that, they then synapse with the olfactory nerve. They're like, well, it says olfactory bulb. Yep, the olfactory bulb is just a more specific piece of the olfactory nerve. Right. But again, this is going to transmit your sense of smell. If you recall, one of the things unique about your sense of smell is that it bypasses the thalamus. The thalamus is, if you remember, kind of the gatekeeper, right, or the gateway to the higher somatosensory cortex regions of the brain, right? All of your senses, touch, temperature, vibration, mechanoreceptors, taste, right, hearing, all of them project to the thalamus, except for your sense of smell. It bypasses the thalamus and does not project to it. Right? So again, here, the underside of the brain, Right, we see this really well established, both sides. Right, the two different structures. Right, the olfactory bulb is kind of the bulbous end, and then the kind of the thinner part back in through here. That's the olfactory tract. The nerve, right, the whole thing is the olfactory nerve. These are just more specific, pieces of it. Next is your optic nerve, or your second cranial nerve. This transmits your sense of vision to the occipital lobe. Right, the eyeball, which will cover special senses next, but your eyeball, the light waves, right, bouncing around the room, enter into the eyeball, and they hit the structure called the retina. Awesome. On the retina, there's all these different, what are called photoreceptors. Remember how we mentioned mechanoreceptors? Those little touch detectors in your fingertips, right? How you touch a table, it distorts that if you look, your skin gets distorted, and that actually distorts the mechanoreceptor, and that's what stimulates the cell to generate an impulse. Think of that exact same thing happening. However, rods and cones aren't stimulated through mechanical pressure, or they aren't stimulated by chemical, they aren't stimulated by chemicals. They are literally stimulated by light and light waves. That's when it actually stimulates them. Right? So the light waves come in, hit the retina, and the retina then, all these little tiny neurons here are all stimulated, and they send those nerve impulses down the optic nerve into, again, your second cranial nerve. So, again, we can see this right here. Right? Now, with this second cranial nerve, right, we can see it, if we kind of go back, right, this would kind of come out into the back of the eyeball. Right, here's an eyeball. Well, I guess it's over here, but it would project down like this. Now, what actually happens is the visual information, some of the visual information from this eye crosses over and projects back to this occipital lobe. Some of from this eyeball crosses over and projects back to the opposite occipital lobe. There's an image we'll look at here in just a second. Actually, in the next presentation, when we look at the special senses, we will talk much, much more about that. All right. But here we can see that X. That kind of forms. Right? The X. The X is something called the optic chiasm, where you kind of have the crossing over of that visual information. Like I mentioned, in the special senses, when we talk about our sense of vision, we will beat that to, not beat to death, but we will definitely take a closer look into that. The third, fourth, and sixth cranial nerves. Now, there is a fifth, absolutely, right? But the third, fourth, and sixth, they are looked at commonly together because of the fact that they all deal with movement of the eye. Cranial nerves 6, abducens, cranial nerves 4, the trochlear, they only do one specific movement. For instance, the abducens nerve. If I am talking about my left eye, I'm talking about my left eye. The movement of me taking my left eye and looking to the left. So for my left eye, that's a muscle called the lateral rectus. That is controlled by the abducens nerve. That is it. That is what it controls. That's it. That's all. That's it. Right. Now, the trochlear nerve, cranial nerve 4. This is going to cause you to look down and in. There's a muscle called the superior oblique muscle that it causes to contract. Again, that's it. That's all it does. Right. The oculomotor nerve, right? It deals with all other eye motions, right? The ability to look up, straight down, the ability to look inwards. Right? All of those are derived from the oculomotor nerve, which is cranial nerve 3. That's not the only thing the oculomotor nerve does. right, is also responsible for vasoconstriction of the pupil. Vasoconstriction. Constriction of the pupil. Right, you go into a bright room, your pupils constrict, get real small. That's cranial nerve 3, or the oculomotor nerve, which determines that. And so, kind of doing progression, we have cranial nerve 1, cranial nerve 2, now we have cranial nerve 3, right here. So, 1, 2, 3. Cool. Here we have 4. Now the trochlear nerve, you can't see where it comes out of because it actually comes out of the back side. It exits off the posterior aspect of the pons, and it wraps around and then projects. Alright, so that's one thing, like on, let me jump back to a better image. This won't work. Right? Here you cannot see the cranial nerve. Actually, that's a bad image as well. Let me go back all the way to the brain. It'll be worth it, I promise. Perfect. Again, on the back side of the pons, about right here. Obviously, it's nowhere near that size. I'm just drawing it so you can see. But this area right here on the back side of the pons, that's where the fourth trochlear nerve, or the fourth cranial nerve, or the trochlear nerve comes out. And when it comes out, it wraps around and then comes out to the front of the pons. Does that make sense? So in certain images, if you look up other images online, you see it coming out of the posterior aspect, or if they talk about, oh yeah, you see the trochlear nerve from the posterior of the brain, you can, right, because that's where it actually comes out of. However, oftentimes it's simply looked at from the front because it does wrap around to the front. That makes sense? Okay. And then abducens. Here's like this big belly looking thing. That's the pons. That's the pons. Abducens comes out almost, not quite on the midline, but directly to the side of it. Right, so we have cranial nerves 1, 2, 3, 4, and here's 6. Okay. Excuse me. Next, we're going to get all emotional. Alright. Next, we're going to look at cranial nerve 5, something called the trigeminal nerve. Now, the trigeminal nerve, a couple of things it's going to do. Again, sensation to the face. So if you touch your face, part of that is the responsibility of the trigeminal nerve. We see muscles of mastication, right? Muscles of so temporalis, right? The masseter, for instance, these muscles are regulated by the mandibular branch of the trigeminal nerve. Right? So when we look at where it is, oh yeah, this big large thing right here. Actually, if I could go back 2 slides just so I don't have to draw arrows again, we see the 5th cranial nerve right here. We see it come off, and we actually see 3, looks like chicken feet, or a chicken foot. Right. Okay. The 7th cranial nerve. The 7th cranial nerve, again, the muscles of the face, right? Muscles of facial expression. We think about movement of the face, right? Movement of the muscles. That is the facial nerve, which is responsible for that. Salivary glands. Again, also your facial nerve. Your taste from the anterior 2/3 of the tongue. That's transmitted via the facial nerve. As far as where it comes out, well, we can see. Right here is cranial nerve 6. Here. That's kind of more in the middle of the pons. As we go laterally, here's where we see facial. Here's where we see facial. Kind of off to the sides. Now, cranial nerve 7 and cranial nerve 8 are buddies. They are very close in proximity. Alright. We're going to see that here in just a second on the next image. The vestibulocochlear nerve. That's cranial nerve 8. Vestibulo, or vestibule, pertains to both the vestibulocochlear pertain to the inner ear. There's two parts of the inner ear. One's called the vestibule, one's called the cochlea. In the special senses, we will look at those. Okay. But the vestibulocochlear nerve is what transmits that sensation into the brain. Right, remember how I mentioned, right, our sense of, regardless of whatever sense it is, touch, taste, temperature, vibration, etc. Right, our sense of hearing, right, even like balance and equilibrium, that's all received, it's all sent into the brain from the inner ear via the vestibulocochlear nerve. And one of the things that we see here, right, the vestibulocochlear nerve is right here. And as I mentioned, it's buddies with the facial nerve. Facial nerve is right here. Here. The yellow is vestibulocochlear. So again, they're very, very close. Right, very close. Oops. Glossopharyngeal. Glossopharyngeal. They're similar to the facial, right, in that it helps to secrete saliva, helps stimulate the salivary glands. The other part is the glossopharyngeal helps to regulate, or it transmits the taste from the posterior third of the tongue. Right, from the posterior third of the tongue. Now we start to get into some more kind of autonomic types of activities. The carotid body, the carotid sinus, yeah, these are little receptors within the carotid artery to help maintain blood pressure. Right? Our brain, well, our entire body, our brain especially, is very sensitive to low oxygen, especially low glucose or just low blood level. Right? You get up off the floor too quickly, you're like, whoa, a little lightheaded. Why? Because that's how sensitive your brain is. Right? It 100% absolutely must have adequate levels of blood at all times. Right? That's why, for instance, if somebody passes out, somebody just scared the crap out of you and you pass out. Well, why? That arises from a drop in blood pressure. Blood pressure, cardiovascular system, that's all 122 stuff. But blood pressure, just by and large, that is how much force your heart pumps with to make sure that blood reaches all of the different tissues of the body. The higher the blood pressure means the greater the amount of force your heart is having to push with. Okay. So if all of a sudden, if somebody just scared the absolute crap out of you, the initial momentary reaction is there's a very fast vasodilation occurring, which means your blood pressure is going to drop drastically for an unbelievably brief period of time. However, I mentioned the brain is unbelievably sensitive to having inadequate levels of blood. So even that very short duration lack of blood flow, you quote unquote pass out. Why? Because your body no longer has to fight gravity. You're now laying flat, and your blood pressure doesn't need to be as high as it once did. That make sense? So down here, and it's kind of in succession, right? Facial nerve, vestibulocochlear nerve, glossopharyngeal, where they're kind of almost like 3 little claws that come out. Now, here's where we start to really get into some of the, right, kind of autonomic functions of the body. Right? This is the vagus nerve. Right? The vagus nerve, you can see, liver, gallbladder, stomach, GI tract, right? It is highly associated with autonomic function. Right? When we talk about somebody scares the crap out of you, heart rate elevates, breathing rate elevates, all that. Those signals to increase the heart rate, increase the breathing rate, were driven, or they traveled along the vagus nerve to reach the heart. They traveled along the vagus nerve to reach the lungs. Right? If you see something, you see food, you smell food, oh, it smells delicious, it smells good, you start to salivate, your stomach starts to produce secretion. It starts to, get ready and prepared for the food you're about to consume. All of those stimulations, or all that stimulation, came from the vagus nerve. Right? Whether it was to the pancreas, the stomach, the small intestine, large intestine, gallbladder, it doesn't matter. Now, in digestion, we'll talk about the enteric nervous system, and that's obviously not, that's not the entirety of the GI tract, right? But the vagus nerve is very important when it comes to autonomic function, GI system function. Vagus nerve right here, quite large. So facial, vestibulocochlear, glossopharyngeal, vagus. So think of like 1, 2, 3, 4, or 7, 8, 9, 10. The accessory, or you may also see it called spinal accessory. Generally, it's just called accessory nerve. That's cranial nerve 11. Right, cranial nerve 11. Cranial nerve 11 controls the trapezius as well as the sternocleidomastoid muscle. Those two muscles. And the reason why those two muscles, right, play a huge role in head movement. Right. There's essentially, there's virtually no head movement which can't be achieved through these two muscles. But the other part of it is also kind of a protective standpoint, or a protective mechanism. Right? Think of like a turtle tucking its head when it's in danger. That's one of the things that the trapezius and the sternocleidomastoid muscle can do. When the sternocleidomastoid muscle contracts, it kind of flexes the neck but extends the head. Right, so think of the position of your head, right? If you had just like really horrible posture, you're slumped forward, head's forward, but your chin is kind of upwards. That movement, not saying the slouching part, but that movement of your neck and your head, that's the SCM. That movement can be, driven from the SCM, the sternocleidomastoid. The trapezius muscle can help to elevate the shoulders. So it's one of the ways that your body can kind of, pack the head on top of the shoulders, right? Almost kind of tuck it, because our head weighs 8, 10, 12 pounds. So in doing this, our body can kind of pack this bowling ball of a head into the shoulders, and it fixes the neck and it fixes the head, so therefore we don't have any unwanted neck movement. Right? Think about, just watch videos of somebody before an accident, or somebody who scares the crap out of somebody. If you watch, their shoulders begin to elevate, their head begins to extend, and their neck begins to flex. Right? It's very sudden, because unless they are continuing to be in danger, but it's a very fast movement. It's a very quick movement, and it's meant to be. It's designed to be. So here we see accessory all the way down through here. Cool. And last but not least, we have the hypoglossal nerve. The hypoglossal nerve. That's cranial nerve 12. That deals with movement of the tongue. Does not deal with sense of taste, does not transmit any taste into the brain. It is purely motor. It purely moves the tongue. Right? So, well, I forgot to mention, so whereas I had mentioned the facial nerve transmits the taste from the anterior 2/3 of the tongue, glossopharyngeal from the posterior 1/3 of the tongue, the vagus nerve also transmits a small amount of taste, and that is from the epiglottis and the glottis. So those are the 12 cranial nerves, like I had mentioned. Right? Those are specialized nerves that even throughout, right, the 122, when we talk more about the different systems, some of the different functions, like the GI tract, like the cardiovascular system, you'll talk a little bit more about different, kind of key aspects and components of those different cranial nerves. In the special senses here in the next presentation, some of the cranial nerves, 1, 2, 3, 4, 6, 8, we will be addressing and talking about different aspects of all of those as well. So thank you, and we'll chat soon.